Okay, so in this lesson, we're going to look at linear inequalities in two variables. Now remember, we learned about what an inequality was previously, and we learned about the less than sign and how to read it. What we're going to do now is incorporate this into solving algebraic type relationship. So we have here ax plus by is less than c. That's an example. Remember, less than means you do not include the value, whereas here ax plus by less than or equal to c means you include the c. And same way with the greater than and greater than or equal to. Now, the same way we had solutions for an equation, we can have solutions that satisfy a linear inequality. Now, remember, with an inequality, you can have multiple values that are less than, greater than, or less than or greater than or equal to a specific value. So, for instance, here we have negative 6, 2, right, is a solution here because once we substitute it in, it becomes a true statement. If we substitute our y value in for 2, and for our x value, negative 6, if we simplify that, 3 times negative 6 is negative 18, subtract 9, and that's going to be a very small number. So 2 is greater than negative 27. And so that's a true statement. So that's what we're going to do here. In this example, we're just going to try to see if these two ordered pairs right here will satisfy this statement. So we have y is less than negative 9x plus 7. So if we try the first one in, we're going to say y is going to be 2. So it's 2 less than negative 9 times negative 2 plus 7. Well, remember, 2 times two negatives together will yield a positive. So that would be positive 18 plus 7. So it's 2 less than 18 plus 7. Oh, yes, it is. That's a true statement. So this one does satisfy, and it is a solution to that inequality. All right, let's try the other one. And if we change it to blue, we could do the same thing. We have y is strictly less than negative 9x plus 7. And we're going to use this one now here. So we have negative 8 for our y is less than negative 9 times 3 plus 7. So negative 8 is still on the left side of the inequality. Negative 9 times 3 is going to give us negative 27 plus 7. And negative 8 is strictly less than negative 27 plus 7. Well, that plus 7 is going to give us negative 20. So is negative 8 less than negative 20? Well, at first glance, it might throw some people off. But remember, on a number line, if this was representing sea level, negative 8 would represent 8 feet below sea level, whereas negative 20 would represent 20 feet below sea level. So negative 8 is actually greater. And this one is actually wrong. This is not a solution to the inequality. And that's the basic gist. We already learned how to solve some inequalities. Now we can check to see if a solution is part of an inequality. Now what we want to do now is take our understanding of graphing and use that to graph what an inequality will look like. Because remember, y less than 3 is different than y equals 3. Y equals 3 means one exact value, a unique value. Y less than 3 could be negative 2.9. I mean, sorry, no, negative 2.9 would work. It could be 2.9, 2.1, the number 2 itself, 1, 0. It can have in essence an infinite amount of solutions that can satisfy it. And so because of that, we need to represent that on a graph in a unique way. And here are our steps for that. We'll graph the linear inequality in two variables by simply graphing what we call the boundary line of the inequality. That basically means we graph just a regular equation. We act like there's an equal sign. The only difference is what the line will look like. If the line is less than or greater than, we will use a dashed line to show that we are not including the values on that line, only less than or greater than. If it has less than or equal to or greater than or equal to, we use a basic solid line like we do with any other equation to show that even that value is being included. Now the second step is how we indicate the multiple values I was just referring to. Because we can refer multiple values, what we're going to do is shade. I'm just going to shade. Now, what the book has is what they call a test point, but there's an easier way to do that, and I'll show you once we get to it. But we're going to shade the appropriate side or plane of that boundary line to indicate what other values could satisfy the inequality. All right, so here's an example. Here we're going to draw the x and y plane. Right, so just make sure you use a ruler. But we have our x and we have our y. And you remember you draw y equals to -2 first. But before you do that, you need to see, is it a dotted line, dashed line rather, or a straight line? And because that's less than or equal to, you would make a dashed line at -2. So -2 would be about here, -1, -2. You draw a dashed line through that, and remember y equals is a horizontal line. So you have a horizontal line that comes through there to represent that you actually do not include the value 2. But now we need to decide where we're going to shade. Now in your book, you can follow the book's rules there, or you could use the rule here that I'm going to present. Basically, every y value will be less than -2. So what's a y value that's less than a -2? -3, -4. Basically, all the y values that are under the -2 will work. And because of that, we will shade in this area. And instead of me like really coloring it, I'm just going to put these lines to represent that I'm shading in. Now you can technically color that in, but that's a lot of coloring. And you could use different colors if you want. But basically, any value that I choose in this region, any value, would satisfy this. And it has to be just y values because there's no x values included in this. So any y value I choose here will work that's in this region. So if I pick this value here, that's -2, -3, -4, -5, -6, -6 is indeed less than -1. All right, let's do the same thing over here. If we to draw the x and y plane, all right, we label this x and we label this y, and our origin is there. X less than or equal to 1 would mean I need to first draw x equals 1, determine if I have a solid line or dash. Because it's less than or equal to, it will be a solid line through 1, which is about there. So if I change that color and draw my line through x equals to 1, and make sure you draw with a ruler, x equals to 1, then we need to determine, am I shading below or above? And you could pick a point. Sorry, I was doing y equals 1. Forgive me, let me redo that one. We're supposed to do x equals 1, and x equals 1 is a straight vertical line going through the point 1. So if that threw you off. Alright, so we have x equals to 1 will look like that, going through the point 1. And then it says that it's less than 1. And what values are less than or equal to 1? The solid line lets us know that we're dealing with x equals to 1. But because it's less than or equal to 1, it would mean every value that is less than 1 or on the left side of this graph. So there we have it. This would be our shaded region. And any value that you pick on that side, any x value that you pick, so if you were to pick that value or even -3, it's less than or equal to 1. And I actually did my coloring to the y-axis. Alright, so there we go, and you make sure you don't cross that line. Alright, so let's go ahead and go to the next one there in our example. So this comes from your book, number 9 and number 12. So if you look at 9 and 12, I forget what page that is, about 111 I think it is. This comes from there, number 9 and number 11. So we're going to graph it when we're dealing with a diagonal graph. Remember, with the x and y in there, that indicates a diagonal graph. One is in slope-intercept form. The other is in our standard form of an equation, linear equation. So we draw x and y axis once I get control of my pen. So we have our y-axis and then our x-axis. Right, so we have our y-intercept is 7. So 1, 2, 3, 4, 5, 6, 7. Because we don't have much room there, I'll use axis again, as points are a bit difficult to draw here. So we start at 7, and the slope m is equal to -1. But remember to write it as a fraction. That's -1 over +1. And then if I wanted to go the opposite direction, remember we can change the orientation of the sign to the denominator. All right, but for this one, because I don't have much room there, if you draw your graph differently, you might. But because I don't have much room, I'm going to go down And so I want to use the y-axis that has y going down, which was my original one. So I go down one and to the right one, down one to the right one, down one to the right one, etc. And by that time you should see the pattern, and you don't really need all those values. But now you can go ahead and draw your straight line using a ruler. Use your arrows to indicate that it goes on forever. Now the reason why I drew a solid line is because this is greater than or equal to. Now this is where you just want to pay attention, because we are no longer on the y-axis here. In order to know which side to shade, if you don't use a test point like the book points out, is just simply to use the y-intercept, because the y-intercept just represents an easy way to see. Basically, all your values are going to be greater than or equal to every y value on this line. So if you was to choose this point here, it would be above that. And because it's above there, it will be above everywhere. And you can kind of see that already. Any y value is above, strictly above, above. All that shaded region is above every single y value. And that's the easy way to do that without having to do any extra algebra. It's just to use the theory behind what an inequality is. All right, we could do the same thing over here, number 12. Remember, you could use the x, y intercepts when it's in this form by setting each opposite variable equal to 0. So here, let's see, negative 10. All right, so we're going to be mainly in the negative region here because that negative 10. So first, remember, find your x-intercept, and you could do that by setting y equals to 0. If you set y equal to 0, you have x plus 5 times 0 is less than or equal to negative 10. And so that means x is, and technically you want to use equal sign just so that you know where your x is. So when you do this, you're actually setting it equal to just so that you know where they cross on the x and y intercept. All right, for the y intercept, you set x equal to 0 if you remember that from a previous section. And we could use equals just to find where it touches on the x and y. If we solve that, 5y equals to negative 10 would mean that y is equal to negative 2. So that means I'm going to have a point at x equals negative 10 and a point at negative 2. So I really just need the third quadrant here. All right, so we have 0. All right, so we go by 2's here. So this will be negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, etc. Now on the y-axis, since it's not that many, we could just go down. We could go these by double, so you could go by ones as well. But I'm just going to have here, this represents negative 1, negative 2. As long as you're consistent on each axis, you're fine. This is be negative 3, negative 4, negative 5. All right, so our points is a less than or equal to, so we're going to have a solid line. And our y touches at negative 2, and our x at negative 10. And negative 10 was here. So that means we have a solid line because it's less than or equal to, going through these points. And then we need to decide where we're shading, above the y-axis or below the y-axis. And because the y value there, now this is where you have to be a little bit careful. When you do this method, sometimes you have to solve to be in y slope intercept form. But here you could kind of see it. But just to show you what I mean, you have to say 5y is less than or equal to negative x. We bring the x over. Subtract 10, divide everything by 5, and you can still see that y would be less than or equal to the line if you use this method. Everything divided by 5. Alright, so basically you want to shade everything below the y-intercept or the y-axis. Or the graph, which represents the y. And so that means everything below where the y-intercept is. And so you shade all that region. Alright, and so you see below the y value, everything below that is shaded. Everything below is shaded. Below the y. Below the y. Remember, the y represents the graph. And so basically you're shading there. And anything that you pick from this region, any point, and the same for the other. If I was to choose this point here, just a random point, that's negative 13 on the x-axis. So I chose negative 13 and negative 13 and negative 3. If we substitute into that inequality, it will work. So I'll work it out here. My x is negative 13, substituting into number 12, plus 5 times negative 3. If that is less than or equal to negative 10, we know we've done it correct. So we have negative 13. 5 times negative 13 is negative 15, less than or equal to negative 10. And if you add those two together, you get negative 28 is less than or equal to negative 10, which is true. And if you just do that for any point, you will see it works. If I choose a point outside of the boundary, so let's say that point there, that point would be, we're skipping, so that was 2. So this would be the point 2. Let's go down 1 to make it easier. 2, negative 1. Right, if I substitute 2, negative 1 in there, it will not work. So 2 for the x plus 5 times the y, which is negative 1, is that less than or equal to negative 10? And so we have 2 plus, plus negative 5 is negative 5. And 2 plus that's going to give us negative 3. But negative 3 is actually greater than negative 10. So this one is wrong. It fails because this point is outside of the boundary. Same thing will work if I chose a point over here and substitute it back into number 9. It will fail. Right? So that's basically the graph shows us how the inequality is true.